So I'm Kyle. I'm a senior software engineer at a company called Tech, and I decided I'd like to talk. After a couple of years ago, I became a vegan after watching a bunch of documentaries online about environment, sustainability, and animal agriculture. A lot of what I saw shocked me, and that's kind of what prompted the change to veganism, and then later on to take up talking about sustainability and technology. So a little bit about Tech for a start. Tech offer digital technology and data services to the UK public sector. We do this through helping them to modernise their practices, accelerate the digital and technology delivery, drive them to make smart decisions through data and automation, and enable them to use sustainable technology and delivery skills. So before we can start to take a look at the steps we can take to start making the software we build a bit more sustainable, we should probably start at the beginning and get a better idea of the resources we use day to day in order to understand the impact we're actually having on the environment. By this impact, I mean the resources we use when designing services, engineering components, deploying them to a particular platform, and then hosting them in the long term. So the first resource we use a lot of is electricity. Data centers across the world use between 1% and 3% of all global electricity produced. And 416 terawatt hours is the amount used by data centers in 2015 alone. The problem with the majority of this energy is that it's not generated from renewable sources. Around 47% of the UK's energy in 2020 was from renewables. Even including biomass and nuclear, as much as they are a bit controversial, only brings the total up to around about 60%. 2020 was classed as a record-breaking year, and even with these numbers, it meant that 181 grams of CO2 was produced per kilowatt hour. And then on average, the UK alone uses 300 terawatt hours. So as you can see, the amount that we use in the data centers alone is a significant amount. So to put this into a bit of perspective, the average solar panel located in England generates around 3,000 kilowatt hours per year. And this is in ideal conditions, so on a pretty sunny day as well. The average wind turbine, however, in ideal conditions, generates around 6 gigawatt hours per year. This means to produce the 416 terawatt hours used by global data centers, 146 million solar panels or 69,000 wind turbines would be required. Taking this, Habitat for Humanity have said that still at this point in time, over 1 billion people, or 13%, still have no access to electricity at all. The other resource we use quite a lot of is water. Water is generally used as a coolant for the hardware or to reduce the temperature of the air in the data centers. 626 billion gallons of water was used by US data centers in 2014 alone. And 1.5 million of that was used by a single Google data center in 2021. So to put this into a bit of perspective, 77 gallons of water is used per day by the average household. And a medium-sized data center uses the equivalent of around 8 households. This is in a day and age when a large portion of the world still has little to no access to clean running water. So now that we're a bit more aware of the actual resources we use in day-to-day, it's time to take a look at the impacts we can have, the actions we can take to mitigate that impact. I'll split these into two categories: fairly high-level technical improvements that teams can take, and then actions for non-technical teams, things like the HR departments. So the first major step would be to migrate to cloud-hosted infrastructure. Cloud-hosted infrastructure, traditional infrastructure uses around 12 to 18% of its total utilization. And in comparison, cloud utilization is around about 65%. This is due to the shared hardware that comes between the two. 33% of enterprise infrastructure still hosted on on-premise infrastructure in 2022. This means that if we can move these to cloud-hosted infrastructure, we could save 77% fewer servers and reduce our carbon footprint by around 88% in total. The next step would be to compare the cloud providers that we choose. There is no right or wrong answer with this, but there are pros and cons to each different provider. So the questions we can ask are, is the provider investing in clean energy? Is the provider offsetting their carbon footprint? Does the provider provide carbon footprint metrics? And is the provider researching ways to reduce their impact even further? These days, most major cloud providers, including Amazon, Google, and Microsoft, all offset their own energy costs. They also invest in clean energy which is in line with their own ESG goals, reducing running costs, and allows them to price a bit more competitively. Out of these, only Amazon and Microsoft have publicized their efforts to innovate in order to reduce resource use even further, with AWS using reclaimed water or recycled water for their cooling, and Microsoft pioneering liquid immersion cooling. Adopting a serverless architecture allows us to improve the utilization they're already receiving from other customers. So adopting a serverless architecture means using managed infrastructure with a pay-as-you-go pricing, mostly shared hardware, and a high scalability and elasticity. This pricing encourages high utilization as we should then use it for a bit better sharing between all the different companies using it. So with things like Amazon Lambda, the hardware underneath is used for provision for multiple servers and customers. With this pricing, the money that we do save cannot then be used to offset our own emissions, which again helps in the fight against climate change. Using the shared hardware, like I said, means that the 35% utilization wasted by the average customer is then pooled to use amongst the remaining customers. Scalability and high elasticity allows us to increase or decrease our usage based on traffic and other golden metrics. In this day and age, it's still an estimated 40% of adopted serverless, so there's still a good 60% that can still make the change. Following cloud architecture best practices. There are a bunch of best practices, including the well-architected framework. The key pillars of this are security, reliability, performance efficiency, operational excellence, and cost optimization. Each of these pillars have their own benefits, but overall they contribute to preventing idling and waste processes or improving efficiency overall. Improving efficiency and preventing idling means that we use less electricity across the course of our application's runtime. Increasing the visibility of your application, of your impact. So this helps us provide evidence-based monitoring, which helps us produce reports and build awareness of what we're actually using and how much of an impact it's having in the environment. There are a bunch of different methods of doing this. So you can monitor websites through host checks provided by the Green Web Foundation or Whole Grain Digital's website carbon calculator. This calculator takes 5 criteria, including data transfer over the wire, energy intensity of web data, energy source used by the data center hosting, the carbon intensity of the electricity used, and the general website traffic. All of these are used to then give an average carbon footprint for the website itself. You can also use Code Carbon Python package to monitor your backend services. I'll go into a bit of this next. There are also a bunch of tools from each of the major cloud providers. Each of these give the emissions data for each of their servers and services, so it gives you a bit of insight of how they are running themselves as well. So taking a bit of a look at code carbon then. So to install, you just use pip install carbon, and then picture on the left is showing pretty basic setup and usage of it. So there are also decorator and context manager implementations available, but this is just a pretty simple start and stop as though you're using a general timer. How this works in the back end is after you've started and stopped, it'll output a CSV file of a bunch of useful metrics, including the energy usage, the runtime, and then using a couple of figures in the back end, it uses those to work out what the carbon footprint is. So from there, we can write a script something like this, which this uploads to Amazon CloudWatch, and you can use that then to create a dashboard like the one on the right. The script I run for this dashboard on the right-hand side took roughly 54 milliseconds, which only equals to around 0.0006 kilowatt hours, but it's just a demonstration of how exactly you get this running and showing to increase your visibility. Obviously, if you're using this in a production system, those numbers would be significantly higher. As I mentioned earlier, though, it's not all about the engineering teams. There are also actions that non-technical teams can take, as they're also working behind the scenes and have their own carbon footprint. So these teams include finance teams, HR teams, sales, and marketing teams. So it can provide documents and processes. So there are a bunch of different ways of monitoring and assessing your carbon footprint. We've already mentioned Code Carbon and the cloud provider tools such as Microsoft Emissions Impact Dashboard. There's also things like AWS's Carbon Footprint Calculator and Google's Carbon Footprint tool. There's also this EcoVadis, which EcoVadis is a ratings provider for helping you to understand your social responsibility. And one of the key pillars in that is your environmental impact. You can also put policies in place, such as environment and sustainability policies. These set out the vision and expectation of your company and how you're going to do business in the future. And you can also take up certifications like the ISO 14000 family and B Corp certifications. Some of these then feed into each other because the different certifications quite often ask for these policies and different methods of monitoring to be in place, so they'll help towards things like that as well. The benefit of having all these in place is that it does give you a bit of a marketing edge over your competitors, and it also gives you solid evidence for your efforts, which you can also then provide your clients for bids and things like that. It can also help empower climate-friendly choices. So you can do this through things like employment benefits. One of the most common benefits is pension funds. Around 50 trillion is invested through pensions. That's coming from the OECD in 2019. In the same year, Morgan Stanley estimated the money needed to meet to finance in the Paris agreements is also 50 trillion. But the problem with this is the majority is invested in environmentally damaging industries like fossil fuels. So just moving your pension from the standard fund to a more ethical and sustainability fund is generally significant impact alone. You can also promote climate-friendly travel. So there are a bunch of schemes here that can be put in place. Taking train or bike can reduce your carbon footprint by around about 75%. And it also has the added benefit of improving fitness, which then reduces sick days used overall, according to a couple of studies. You can also provide plant-based food and drink options more. So the average diet takes around about 2.5 to 3.5 tons of CO2 per day to sustain. To compare, a plant-based diet takes around about 1.5 tons of CO2 equivalent per day. So you're saving between 1 and 2 tons of CO2 every time you eat in a day. So putting in place things like Meats Mondays or veganuary can also have an impact here as well. And then providing recycling bins in offices. There's a number of studies being done on things like this that can change the way you actually put it in place. Things like signs have been proven to improve recycling rates, particularly when they're around bins areas. But on top of that, there's also studies into how reducing the size and number of waste bins you provide also improves the recycling rates. And finally, extending a product's lifespan. So the first action for this would be removing single-use items from office spaces. So a lot of offices use cheap disposable pens rather than using more expensive refillable pens. That's just one example, but there's also things like using cloths rather than tissues and things like that, which you can do. Resource sharing and trading. So this idea kind of came from a WhatsApp group on my local housing estate, where people offer products before they dispose of them. And this can take many different forms, from furniture to patio slabs to wooden pallets. They've had deliveries, and people will take them and just use them for their own thing rather than actually going out and buying them themselves. So that extends the product's lifespan a bit further than usual. So we took this a bit further and we took it into the organization. So we've produced Slack channels where people can offer their products and things that they finish with. In our case, this is usually things like textbooks and things which are used for learning and development. So it means that rather than that book being stuck on a shelf in somebody's house after being read once, it means that it gets shared around, the knowledge is extended, which also reduces expenses and fosters a bit more of a community sense. And then purchasing supplies from sustainable sources. So there's a bunch of these available. There's things like B Corps and things which all will have their own way of doing different products which are a bit more sustainable. All of these kind of feed into the whole idea of a circular economy, which helps reduce the waste a bit further. Majority of this talk has been focused on reducing, but this is a bit more on the reusing side of that. And finally, the key takeaways from this talk. So we talked about the impact that we're currently having on the world. 1 to 3% of all electricity is being used by data centers globally. And then over 600 billion gallons of water is used by data centers annually in the US alone. Some of the solutions we talked about were we could migrate to cloud infrastructure, which can help reduce our carbon footprint by up to 88%. Choosing serverless and best practices means that we use less waste and idle less, and makes everything a bit more efficient. And then using tools like Code Carbon and other cloud provider tools to increase the visibility of our carbon footprint and promote a bit some more sustainable choices.